Lab 3 is about the magnetic field of permanent dipole magnets. The purpose of this lab was to measure the distance dependence of the magnetic field of a small bar magnet and compare the measurements to the predicted equations derived. For the experiment, a magnetometer app was used to measure the magnetic field. For the result, the mu value was 1.46 amperes times meter square. The experiment was conducted by first finding the magnetometer chip in the phone. The location of the chip was marked by tapes. Then the distance from the magnetometer sensor to the magnet was measured for different Bx values from 20 microtesla to 220 microtesla. Lastly, the off-axis magnetic field was measured. This is the table for the measured distance from the magnet to the sensor depending on the x component of the magnetic field. The table above shows the measurements of off-axis distances and respective magnetic fields. The plot below shows the ln Bx versus ln distance plot. The y-intercept of the line, which is negative 12.149, represents the ln(k) value, and the slope of the line is the n value. The principles used in this lab are the Biot-Savart law, equation for magnetic field of a dipole, and the distance dependence equation. The second equation of magnetic field of a dipole is for an axial magnetic dipole. If I set the magnetic field of a dipole equation equal to the distance-dependent equation, I get the first equation shown above. If I solve the equation for mu by plugging in the k, n, r, and mu naught values on the right, I get mu equals to 1.46 amperes times meter square. This is the visualization of the magnetic field at on-axis, perpendicular, and 45-degree positions. The orange arrows represent the on-axis magnetic fields, cyan arrows the off-axis magnetic fields, and magenta arrow the 45-degree magnetic field. For the coding for this model, I first created the magnet at the origin and then created the function for magnetic field, and finally visualized the on-axis, perpendicular to axis, and 45-degree off-axis magnetic fields. If I hadn't oriented my experiment to compensate for magnetic north and laid out my meter stick at some intermediate angle with respect to Earth's magnetic field, the influence of Earth's magnetic field would have increased, so the net magnetic field would have been greater than what it's supposed to be, and therefore interrupting the experiment results. If two identical magnets were stuck together end to end, the magnetic field would increase twice due to superposition. That's it for my presentation, and thank you for listening.